Welcome to Veteran Science Academy. This is Veteran Science Academy. We're interested in making you grounded, grooming you to understand the in-depth knowledge in mathematics. You're once again welcome to Veteran Science Academy. So today we're going to be treating indices from scratch. We want to start indices from scratch up to what the complex. But the complex, don't get confused. The complex will also try to make the complex much easier. We're going to break indices down here. So follow us as we begin this journey, as we start indices in today's class. Now, first of all, before we start, we're going to start with the laws of indices, which is the basis, right? So you can't just start applying it without understanding the laws of indices. And then with the laws of indices, gradually we start building momentum and how to apply them in various calculations, and you'll see calculations on WAEC and JAM. And any question that comes in indices in WAEC, we'll be able to trash them after this class. So I expect you to subscribe so that you watch more of my videos, more of the videos that will be coming out that you'll be seeing on indices, and even subsequent videos on other topics in the future, on other topics you'll be seeing. All right, now the laws of indices is we're going to be stating them, and I'll be explaining what the laws are. Now the first law here is the multiplication law. The multiplication law, the first law here is multiplication law. Let me write it in short. Multiplication law. Now, what is multiplication law of indices? Now, this is what it is. Now, the multiplication law of indices, and if you have a base, if you have x raised to the power of a multiplied by x raised to the power of b. Now, this x and this x, they represent a base. Are you getting it? And why they have a power up, this is called an index. This a is an index, this b is an index. Index means the exponential, the power that the base actually carries. That is, in how extent, how many times are you going to multiply? You are going to multiply the base. That is what the index is telling us. So if I have, for example, if I have 5 raised to the power of 2, and this is my base and this is my index, right? This actually tells me, the power actually tells me how many times am I going to multiply what? My base, which means 5 and 5, because my power is twice, right? That is, the power goes, it's 2 times, the power is 2. So if I have 3 as my power, that means my base has to multiply itself 3 good times. Now, this is the first law of indices, is telling us that when we multiply, when 2 bases are the same, this is 2 bases and they are the same. X is a base and another x is a base. Similar base. When 2 similar bases multiply each other, what happens? The power here are to be added together. So this means that if we have this, what this means is x, we take a common base. There are 2 similar bases. We take a common one, then we'll add upwards the power together, which is a plus b. Are you seeing it? That is what this law is all about. Now, let's apply it with some smaller, simple examples. If we have 2 raised to the power of 5 multiplied by 2 raised to the power of 8, or rather, 3 here, and then we have 2 bases which are the same, right? And what happened to the power? The power are going to be added together, right? So we have 2, which is the common base, adding up the power together. We have 5 plus 3, which gives us 2 raised to the power of what? 8. Now, and some other examples, if you have, let's say, 7 to the power of 4 multiplied by 7 to the power of 2, what happened? The bases are the same. You take your common base and then add up what? The power, which is 4 plus what? Plus 2, which gives us 7 to the power of what? 6. Are you seeing it? Now, this is the multiplication law of indices. When we have a common base, what happens to the power? The power are added together. But if the bases are not the same, let's say, for example, we have 2 different bases. Let's say we have x multiplied by y X is carrying A and Y has the power of B, and then you cannot say, you cannot add up the power together, right? Because the bases are not the same. Now this means that this is not equal to, it can be equal to X A plus B. Are you getting it? Because we don't have similar words. The base here are not the same. What about the Y? Are you seeing it? So this does not work. So whenever you have different bases, it's not possible for you to add up what's the power. That is what indices is actually telling us about here. Now another thing we should know is if we have the second law here, which I will be treating here, is called the division law. The division law. Now the division law, it's just division law, and in the division law, let's take this similar thing: x raised to the power of a divided. Now we are talking about division now, divided by x to the power of what? B, right? Now what happened here is that now the power will be, because of the division here, the division tells us when two similar bases are actually dividing, their power are subtracted. Are you getting it? Now that means if two bases are dividing, something will actually happen to their power. Their power will be affected by what? Subtracting themselves. While here, when the similar bases are multiplied, something affects their power. Their power are still to be added together. That is what this law is all about. So in this case, in division law, what happened here is that we have x a. We take a common base, which is x. The common base here is x minus what? The other power of the other base, the similar base, which is b. Are you seeing it? Now let's apply it in a number. If we have 5 to the power of 5 to the power of 5, right, divided by 5 to the power of what? 2. What does it give us? We take our common base, which is 5 raised to the power of 5. We subtract minus what? Minus 2. That is minus 2, right? So we are doing division law now. This is division law. So the power are subtracted. Minus 2. And so what do we have? We have 5 raised to the power of what? 3. Are you seeing it? So we have 5 raised to the power of 3. As simple as that. Now, this is what this law is all about: multiplication law and division law. And another thing you should know, let me actually expand this, right? Let me expand this for you so that you also understand what I'm talking about. Now, in this case of 5 raised to the power of 5 divided by 5 raised to the power of 2, if we were to expand it, this is what we see. We're still going to have the same answer, but let me expand it. That is the essence of Veteran Science Academy, to actually show you the basis, the in-depth of it, right? From the basic, and from the basic you understand well. So now, if we have 5 raised to the power of 5 here, this means that, like earlier I said, this power tells us how many times the base multiplies itself. This means the base is multiplying itself in 5 places, which is 5 times 5 times 5 times 5. This is times 5. This is 1, 2, 3, 4, 5. Are you seeing it? Division divided. Now this is division, right? So this is it, division divided by 5 in how many places? 5 multiplying itself in 2 places. This is 5 times 5, right? Now what do? Division, we divide. We are dividing now. This cancels this. That is dividing. This also cancels this. That is dividing. So how many do we have left? We have 1, 2, 3, which is the same thing as 5. In how many places? Now our power will be what? Because it appears 3 times. Our power is what? Raised to the power of what? 3. Are you seeing it? So I just actually show you what really happened here, what really transpires here. But if you take it like this, it's still the same thing. The law is still saying the same thing. Now quickly, let's look at another law, which is called the zero index. Zero index. Now in in this law, what happened here is it's telling us that the power being zero, that is, if we have 5, let's say we have our x, as we usually use x as our base here. We have our x raised to the power of 0. What it means is we have 1 as our what? As our answer. So x raised to the power of 0 is 1. We have, this is called the zero index law. Now if we have, or let's say 50 to the power of 0 gives us 1, right? So any number we have raised to the power of 0, 1, any variable at all to the power of 0, 1, 1 million to the power of 0 is 1. So that is what this zero index law is all about. Okay, then number 4, the fourth law we're going to be looking at here is called the product law. The products power law. Products power law. Now this is actually talking about multiplication of what? The power. Now this means, for example, we have x in bracket, okay, we have x raised to the power of a, then in bracket we have b outside. Now this means that this the power here and the power outside are going to multiply, right? Remember, our bracket means multiplication. So we are going to open the bracket, and for us to open the bracket, we're going to multiply a multiplied by b. So what we'll have here is x, which is our base, then ab. Ab is the same thing as a times b, right? If it's number that we have there, we are multiplying it together. So we have x raised to the power of a, b. That is what we have, what we call the product power law. So power actually multiply each other when we have something like this. We have a power, a base raised to the power of a power, a base and a power, and raised to the power of another power. So what happens to the power is that they multiply. Now let's look at a very simple application on this. We have 3 to the power of 2, and then we have 5 here. What happened here is the power are multiplying. So we have 3 to the power of 2 multiplied by the other power, which is 5. So we have 3 raised to the power of what? 10. So this gives us 3 raised to the power of 10. This is what we call the product power law. So there is another law we have. This is, if we have 2, let's say 2xy, for example, right? And then we have raised to the power of 2. Now what happened in this case is still the same thing. In this case, the 2 outside multiplies all the power inside. That is a power inside. All these numbers, the number here has a power. The x here has a power. The y here has a power. The power it has is 1. So it usually does not, they don't usually show us if a variable has a power of 1. So if a variable has a power of 1, it's just that variable itself, right? So we don't really need to put it as x raised to the power of 1. So it's just x already. So when a variable does not have, it's just x, it's just that variable, that means it has a power of 1. When 2 does not have a power, that means its power is just 1, when the power is not indicated. So now, to continue with this now 2 multiplies all the powers inside. This power here outside is interested in multiplying all the power inside. So we are like opening the bracket in our algebra, just like our algebra. But in this case, it is the power. We are interested in the power, right? Now this gives us 2 multiply the power of 1. Like I told you, 2 has the power of 1. So this 2 multiply the power of 1, which is here. Are you seeing it? Then we have x. X also has a power of 1, which is also not usually indicated here. So we have multiplied by, let me just show it for understanding, for those who want to really understand it from the basis. So we have 1 multiplied by 2 also here, and then we have The next one, which is y, raised to the power of 1, it also have a power of 1 here. Okay, multiplied by 2. So, but in our subsequent video, I will not really put those 1 again, because I believe you must have understand what I mean. All right, but for now, because we are starting from the basic, from trash, from scratch, so I'm going to show those things. Okay, now 2 raised to the power of, now 1 multiplied by 2 gives us 2, right? So we have our base, then raised to the power of 2, then we have x here, then 1 multiplied by 2 gives us what? 2 also. The same thing with this one, y raised to the power of what? 2. So this is also part of the product power law, but in this case, the power is 10 to distributed. We don't have one variable, we have 2 variables and we have a number. So the power outside the bracket, is what? Distributed, that is multiplied inside everything that is in the bracket. So we have this as our answer. Now we have applied this various law. Okay, the next law we're going to be looking at very quickly is called the negative index law. Now, negative index law is just trying to tell us that the index, that is the power, carries a negative sign. Now, when the power carries a negative sign, what does it mean? How does it appear? For example, let's use we have x as our base, and then this x is to the power of let's say minus 1. It has a minus 1, right? So what does it happen? What happened here is, now whenever a base is raised to the power of a negative sign, negative index, negative power, it means it results to a reciprocal which is 1 over, right? Now the negative index brings about this thing now, this reciprocal of what? The base. So the negative bring about the reciprocal of the base, that is reciprocal of x. Are you seeing it? So it brings about the reciprocal of x, then to the power of what? The index, to the power of the index, which is to the power of 1. Are you seeing it? But usually, like I told you in the previous video, I will not be putting 1, I will just put it here for the basic. We are starting from scratch. Alright, but usually it's the 1 over what? X, right? You don't need to put this 1 because x here is already telling us that it has just one base. Alright, okay, if we have, let's look at a very simple application. We have 3 raised to the power of minus 2, right? Now what this means is, it's the negative sign brings about the reciprocal which is 1 over what? The base, reciprocal of the base, which is 1 over 3. Then to the power of what? To the power of what? 2. Are you seeing it? So the only thing that happened here is that this negative sign brings about the reciprocal. Remove this negative sign. Are you getting it? Remove it here, remove it, join it together, join 3 raised to the power of 2 together and put your 1 over. Are you seeing it? That is just very simple about the negative index. Are you following? I hope you're following. So with that, we are good. So this is what we have. Now, in other cases when we have fraction, if you have fraction, example, if we have x over y, x all over y minus raised to the power of minus 1, how do we do this right now? Right? Remember we talked about the negative index brings about reciprocal. So what happened here is we have 1 over what? X over y. Are you seeing it? X over y. So for us to take out this reciprocal sign, the negative, the denominator here is going to be an exchange. So this comes up and this goes down. So what we have this, we have y over what? Over x. Are you seeing it? So whenever we have a fraction which is our base raised to the power of a negative index, what happens is that the fraction changes. They change. The denominator comes to the numerator, and the numerator goes to the denominator. There's an exchange, just like what you are seeing here. Are you following? Okay. If I have another instance, if I have, let's say, let me not use 1. Let me use another number. We have x over y raised to the power of minus 2. What does this give me? Now this gives me the next reciprocal here. The minus brings about the reciprocal, which is 1 over x over y. Are you seeing it? Raised to the power of what? 2. Raised to the power of 2. I told you what happened here is the reciprocal, this minus, this negative sign, negative index, brings about the reciprocal. Then quickly clean up this, bring it together. Bring it together, put your negative, your 1 over, your 1 all over, which is your reciprocal. Are you following? So that is all. Then, now we have this like this. Now the next thing to do is to exchange. The numerator comes to the denominator, and the denominator goes to what? To the numerator. Now let's quickly do it. We have our y comes up, it becomes y over, then x goes down, it becomes x. And then we have, close it up, raised to the power of what? 2. Are you seeing it? So this is the laws of indices we are looking at right now. Also, in the negative index law, if you have this, you have 1 over x raised to the power of the negative index of 1, of minus 1. What do we have here? Very simple. So what we have as our answer is we have x. So whenever we have this, we have x. We have 1 over x raised to the power of minus 1. We have x. How? Let me quickly show you. Let me quickly break it down. So what happened here? This is, so pay attention. We have 1 over x gives us 1 over x raised to the power of minus 1. So this is what happened. Remember I told you, whenever we have a negative index, it brings about what? A fraction, right? It brings about a fraction, a reciprocal. So the reciprocal we have is 1, 1. Then we have 1 over what? X, which is this 1 over x, right? Raised to the power of what? A 1. Are you getting it? Which one? Which is this? Well, usually you don't need to put this, like I told you. Now, in this case now, what happened? What happened here is there will be an exchange. There will be an exchange. And so this exchange results to giving us 1x as our answer. Result to giving us x our answer. How? Because we have, let me show you here. We have this 1, right? Multiplies by, so this x comes up. Have it like x like this, all over 1, and x over 1 is the same thing as x, right? So we have, this is x already, and then 1 multiplied by x gives us x. This is how we got this. So whenever we have 1 over x, or 1 over a number, 2, 3, 4, is raised to the power of a negative index of 1, you see the same thing as what? That particular base. So, okay, for example, for instance, let me use a number to give an instance on this. If you have 3 raised to the power of minus 2, okay, 1 over 3 raised to the power of minus 2, my answer is 3. Raised to the power of what? Raised to the power of 2. This is my answer. How? Now, the reciprocal, let's break it down now. That is the essence of Veteran Science Academy, to break it down so that you understand the basis of all these things. Now, we have this negative index shows us the what? The reciprocal. So, 1 over 3 raised to the power of minus 2. Now, the reciprocal brings us up, and the negative index brings about what? The reciprocal, which is 1 all over 1 over 3 raised to the power of what? The index without the sign. Are you getting it? That is the positive index now. And here, what happened? There will be an exchange. There will be an exchange that results like this. The negative index already brings about what? The exchange. Now, the negative index, this reciprocal, brings about the exchange of the fraction. So the numerator comes down, the denominator goes up, like what we have done here. We have subsequently been doing here. So that is the similar thing we're going to do at this point. So here we have 3 over what? Over 1 raised to the power of what? 2. And 3 over 1 is still the same thing as what? 3. So we have 3 raised to the power of 2. That is exactly what we did here. So that is that about our negative index law. So in our subsequent videos, we'll be applying them. Well, let's quickly look at the last law we're going to be looking at here, the law called the root power. The root power or fractional index. Now, we looked at cases where our base is a fraction, like we have a base like x over y raised to the power of maybe 2 or negative 2, right? Like this, right? Now, let's look at a case where our index now is a fraction. So that is what results to what? The root power. So when index is a fraction, it gives us root power. Now, if we have, for example, x raised to the power of, we usually use x as our base, x raised to the power of, let's say, 1 over a. Now, this is a fraction, right? Now, a fraction is the index. The index is a fraction. We look at when the base is a fraction. Now, in the cases where the index is a fraction, it brings about a root power. Now, this is written like this. The root of our base, the root of x, are you using it? The root of what? X. We have a here. That is the root of x. Are you using it? The root of x, then we have a here. And then this one can be written here. Are you getting it? But we don't need to put it. We don't need to put it because it doesn't change anything. 1 does not really change anything. But the essence of this video, I'm going to be leaving it there for those of us so that we can follow from the scratch. We can still leave this thing is still the same thing like this. It's still the same thing as saying the root like this. Are you seeing it? So now, in another case where we have x, we have b over a. This is another fraction as our index. Now, in this case, we have the root of the x, which is this. Now, our a comes to this place. This is where we have our a. So, whatever number that is here comes to what? Here, comes to this place in the root. All right? So, if it's 2 that is here, it comes to be the square root. Are you getting it? So, here we are using alphabet now, variable. So, this is our a. It comes to this place, right? And then to the power of what? So any number that is in the numerator on the fraction comes as the one at the top. That means power of b. That means when you have finished solving, looking for this, you just quickly find it, square it by just find the power of b of it. Okay, let me give you an example of what I mean. All right, in a case like this, if we have applications, we have okay, if you have 4 1 over 2, 4 1 over 2. Now this place, in this case, we have the root of what? This is a fraction. Now 1 over 2 is a fraction and is an index. So the root of 4, are you seeing it? Is root of 4. So here, where are we writing? What are we writing here? We're writing 2 at this place. So we're writing 2 here. That is square root. Are you getting it? But usually in square root, you don't need to write these 2. But for the case, for the essence of this teaching, as we are starting from the basis, let's show everything. So raised to the power, putting our 2 here is very necessary. Then raised to the power of, cover everything with what? With 1 to the power of 1. Are you getting it? Or for the help of this teaching. So this is the same thing as saying the square root. Let me just write it like this: square root of 4, right? Are you seeing it? The square root of 4. But this is actually what happened here. This your 2 will be written at this point, which is the square root. Then the power, this 1, it's after finding the square root of 4, you raise it to the power of 1. That is what happened here. And this is the same thing as writing it like this. As this is very short in writing it, so we don't want to jump steps. So the square root of 4 gives us exactly what? 2 as our answer. So I believe you know what square root is. Square root is 2 numbers that can multiply itself 2 times. And it gives us 4, which is 2. So then, if we have another example, we have, let's say 27 raised to the power of 1 all over 3. Now, in this case, what do we have? We have 27 raised to the power of 1 over 3. So the root of what? The base. Which is the base? The base is 27. Are you using it? The root of the base, which is 27. And what is the 3? Now, it is not just the root, it is the cube root, because we have 3 at this point. I told you, whatever we have as the denominator, the fraction index will bring it what? To be here. Are you seeing it? If it's 3 that is in the denominator here, it becomes what? The cube root. If it is 4, it becomes the fourth root. If it's 2, it's square root. Are you getting it? So here we have 3, it is what? The cube root. So we have the cube root of 27. We'll cover it up to the power of what? 1. But if you prefer not to do this, it's still correct. Not to cover it with power of 1, because 1 does not really change anything. So we have our answer as the cube root of 27, which gives us what? 3. And how do we get cube root? That is 3 numbers multiplies itself 3 places and give us 27, which is 3 times 3 times 3 gives us 27. Okay, another example before I continue. Okay, now we have 16, the square root of 16, we have 16 square, or rather 16 raised to the power of 3. And this is what we have. So what do we do? At this point now, I have told you, now the fraction, first of all, the fraction brings about what? The root power, right? Now what we are doing is the root power of what? 16. The root of 16 first. The root of 16, are you using the root of 16, which is the base, right? Then so what are we deciding? Is it square root or cube root or fourth root? It is square root, because the denominator here is 2. Are you getting it? So the denominator is written here. Is written here. Are you seeing it? It's written here. Are you seeing it? Are you seeing it? So while we're covering it up, these 3 up at the numerator, it should be written up here, meaning that after looking for the square root of 4, we multiply that 4 in 4 places to get our answer. Now, very simple. We have here the square root of 4 is already given to us as what? 4. So we have 4 to the power of what? 3. Are you using it? So multiply 4 power of 3. We have 4 times 4 gives us 16. So 16 times 4 gives us 64. So we have 64 as our answer. So I believe you enjoyed this video, and in our next class, we are going to be bringing different applications. We're going to be solving different examples on indices. Solve different examples on indices and bring some other wire questions and jump questions in indices and trash them, and you understand indices like a veteran science academy student. Thank you very much for watching. Meet you in the next video.